In this section, we will talk about the indeterminate form, one of the indeterminate form, which is a product form, 0 times infinity. But we remember we do have 7 indeterminate forms, and we know how to deal with them, how to calculate, how to investigate them, and especially 0 over 0 and infinity over infinity. 0 over 0, we will try to find a common factor, common 0, and also infinity over infinity, we know which function grows faster, which we actually using the relative rates of growth, and we can also get the output, get the answer. Actually, one more thing. This section we talking about the indeterminate form, this one, but we will not use the L'Hopital rule. Okay, this is just using algebra, okay, and calculus, but no the L'Hopital rule. We will have another section which we will deal with the L'Hopital rule. We actually have to do it because it's important tool, but we can still look at easy examples without the L'Hopital rule. Okay, that means yes, 0 over 0 and infinity over infinity, it's quite easy, but when we see the other forms, for instance, 0 times infinity, what we can do, I can show you that we may easily rewrite algebraically as a quotient. Instead of looking at the product, we can rewrite as a quotient, and then it's easier to analyze the form. Okay, that's my product form. Just to clarify, because we talking everything what we see here is symbols. It's 0 means that the function is approaching 0 at the certain conditions, certain numbers. Function is approaching infinity. Function is approaching 1. Okay, that's not exactly, we know infinity is not a finite number. Okay, then let's see. Limit as x approaches a, function f of x goes to 0, function g of x goes to infinity. When we end up having product of f of x times g of x, we end up having indeterminate form 0 times infinity. And now this is indeterminate form. We learned that this answer could be actually anything. Could be 0, could be infinity, negative infinity, and could be even the finite number. Yeah, everything depends on the expression of the function. And we have to look at this. That means when you see something like this, 0 times something that's undefined, yes, please take the big, breath, breathe in, and then think, yes, what we have to do. Okay, so now let's look at this. Product, which is f times g, can be easily rewrite as a quotient. But and we also know, we will not look at the moment at the L'Hopital rule. Okay, but what I'm saying, when we have product of two functions, for instance, x times natural log of x, okay, I can keep natural log of x and I can flip x. Yeah, and then I'm creating ratio of two different functions, but it's still the same. Yes, the same. I didn't change the original expression, and I just rewrite product instead of the quotient. For instance, if we will say x times tangent of x, I can possibly keep x on the top and flip tangent. 1 over tangent is cotangent. That's even nicer. Please remember, always one of the factor, we can flip it and rewrite as a quotient, because dividing by fraction means multiplying by the reciprocal. That means this is maybe one of the steps later, even for the L'Hopital rule, or even without the L'Hopital rule. That's I just wanted to tell you this, and then let's just look at a couple of easy examples. That means, for instance, we have 3 limits on this page. They are actually at infinity. Okay, x approaches infinity, and they create the form 0 times infinity, because 1 over big number goes to 0, x cubed at infinity goes to the infinity. That means yes. That we can see this is indeterminate form. And this is actually a product. I can easily rewrite like this. then I'm creating actually the quotient. You may notice I did create infinity over infinity, but we don't even need any rules, any extra rules. We can simplify it, and x squared at infinity goes to the infinity. That's the final answer. Okay? Let's look at this one. 1 over big number is a small number. X cubed at infinity is also infinity, which actually we have indeterminate form. But when x goes to the infinity, x cubed over x to the power of 4, we did create infinity over infinity, also interesting. Yes, and when we simplify, it's 1 over x. Hyperbola 1 over x goes at infinity goes to 0. Okay, or we can think 1 over big number, small number. And the last one, 1 over big number is a small number, x cubed goes to the infinity, at infinity. We can simplify right away, and we have infinity over infinity. But this limit is, of course, we may simplify, and limit of the constant is a constant. Okay, that means this limit is 1. That's we can see 0 times infinity can lead us to anything. Infinity is 0 or finite number. Okay, exercise number 2, almost the same thing. Yes, but now this limit is as x approaches 0 from the right-hand side. But also these expressions create indeterminate form, the product, indeterminate product. 1 over small number is a big number. X cubed at 0 is 0. That's we do have this one. When we multiply, I know that we can cancel out right away, but just to rewrite, just in case of the more complicated function, then we actually created 0 over 0. But this is x squared, and at 0 is 0. Okay, and again, 1 over small number is a big number. X cubed at 0, it's 0. No. And let's see, we may notice what is happening. X cubed over x to the power of 4. It is 0 over 0, but we don't need extra fancy tools, just algebra. Oh, it's from the right. And 1 over small number is a big number. We know that is from the positive part is positive infinity. And this one, I just wanted to show you 1 over small number is a big number. X cubed at 0 goes to 0. We still have indeterminate product form. When we rewrite like this, algebra, we did create another indeterminate form. That means they are so close. The product, it's so close to the quotient. And now limit of the constant is a constant 1. Okay. So nice, but it's important. I know that you will think it's so trivial, but in case of more complicated expression, remember, create a quotient and maybe use the Hopital rule, but that's later. We still don't know the Hopital rule, but we still can manage. Okay, and this one, the same idea, but I just wanted to touch the relative rates of growth. 1 over big number, small number, e to the x at infinity, of course, is infinity. Indeterminate product form. When we do this, okay, that's when we definitely have infinity over infinity. Both of the functions goes to the infinity at infinity. And we may say that this limit actually is infinity because we know e to the x grows much, much faster than x cubed. Yes, I'm just of course, I am using the relative rates of growth. Okay. And if the numerator is winning, is infinity. Okay, now natural log at infinity is infinity. 1 over big number is 0. E to the x at infinity is infinity. indeterminate product. Let's change for quotient. We know how easy it is. And now we have a battle between, because it is infinity versus infinity, e to the x, ln of x. But we know again, natural log grows much way smaller, slower than e to the x. That means e to the x is winning. Oh, that means again is infinity. I wanted the other way, but it's okay. It's okay. It's infinity. It's infinity. Okay. And then 1 over big number, small number. Natural log at infinity is infinity. Now I have the other way. Natural log of x over e to the x. Infinity over infinity. But now, actually, that's the same relation. E to the x grows faster. If the denominator is winning, it's 0. Yeah, I just didn't have, let's maybe do one extra, because probably I was thinking, let's just say what we can do. Let me do the quotient right away. I just want to show you 2 e to the x plus 1 over e to the x plus 5. That's the leading function is e to the x, e to the x. We definitely have numerator and denominator going to the infinity. But since they are the same, the ratio of the leading coefficients, because 2 and 1, the answer is 2 over 1, it is 2. Okay? That means just showing you, and I can also rewrite this as a product. 1 over e to the x plus 5 times 2 e to the x plus 1. Okay? That means it's also would be the product, but we managed to have the quotient, and this is the finite number, just showing that we may have an answer infinity, 0, or finite number. Okay, and then I have last question, multiple choice. Let's pretend if you will see this on your test, on your quiz, on your midterm, on your final, what we will do. X goes to the infinity. That means this is infinity. E to the negative x at infinity is 0. Okay, product form. That means we may, product again. Yeah, we know product is like, we don't know. When we see quotient, it's much better. But I can rewrite this like that. So easy. X and e to the x, both of them goes to the infinity. That's when we have infinity over infinity. But e to the x grows much faster. Yes, e to the x, relative rates of growth grows faster, denominator winning, it's 0. The answer is 0. Okay, so please go through all of these questions possibly again and enjoy that indeterminate form, the product form, that product form actually without using the Hopital rule yet. Okay, thank you.